Dear friends, in this experiment, the name of experiment is operation amplifier inverting and non-inverting amplifier. And here the main aim of this experiment is we are going to construct an inverting and as well as a non-inverting amplifier. We are going to use again operation amplifier as we have used in the Wien bridge and as well as phase shift and as well as in the both experiments. So 741 op-amp only we are going to use, and even though we are going to compare this theoretical value to the practical values of that voltage gain of that DC input. And let us see the requirements, apparatuses which are required to perform this experiment. We need IC 741, that is what, as I said, that the operation amplifier, which is the ideal op-amp, and we need the register values up to 1 to 5 kilo ohm and as well as 10 kilo ohm. Here we are going to use, we have used in this experiment 1 kilo ohm and as well as here this variable register as the decayed resistance box we have used, so that we can change up to value to the 1 to 10 kilo ohm, 1 kilo ohm, 2 kilo ohm, like that. We need the connecting wires and as well as we need the breadboard also, and even though we need the two regulated power supplies and the multimeter. And you can see here in this this is what the multimeter we are going to use in this experiment, and as well as the breadboard 741 op-amp, that is the IC, and here 1 kilo ohm of resistance and connecting wire, and these are the connecting wires. And here also we are having that inbuilt power supply plus 12 and minus 12 voltage, and 0, that will be the ground. And here we are having that another one power supply, that is IC regulated battery eliminator is there, up to we can vary to 2 to 12 voltage. These are the two power supplies which is inbuilt and which is the outsourceable. And here we are having the decayed resistance box. Whichever we can choose the variable resistance, we are able to choose. There are 5 variables are registered in this decayed resistance box, as you can see here. And now, so these are the simple apparatuses which are involved in this experiment, both inverting and as well as the non-inverting, which is a simple experiment. As you can see, the components are very less, and even though it's a very simple connection also, you can see here already the few are connected. So let us see here. We have considered this 741 IC, and this is the dark circle is there, so it means to be we have to start here from 1 2 3 4 and here 5 6 7 8. You know that 6 is always output and 7 is there and 4 is there, which one is the plus VCC, another one is the minus VCC. And as you can see in the circuit diagram, so that you can get it here. So 3 from 3 to where that has gone, that is, this is nothing but what, this is the ground. So now I can give this simple connection. So you can choose this wire. Here we are having the terminal 3, so I can choose this is the ground. Okay, so 3 to ground, that's all. And here we are having the another one, feedback resistance, RF is there, 2 to 6. So now I have to choose the 10 kilo. Here we are having brown, black, orange. So now let's fix that one to the 2 to 6. So it's been done. And now from the pin 2 only, we are having the one variable resistance box, that here we are having. This is the decayed resistance box which is variable. So now I can give this connection from 2 from the second pin I have given. So this is 2, and again another terminal of this decayed resistance box where we have to give to the positive terminal of the input voltage. You can see here in this circuit diagram. So from another end is that comes to the positive end of the input voltage. Here we are having the input voltage. Here we are having that. This is the input. I can give here. So let's. So now I'll make the connection here. So now we remain with the another end. Again this. Another end that will comes to the, of course, that is comes to the ground. As you can see in the negative end, that will goes to the ground. So now I have given in this ground. You can give here also, as you wish. But between this, here the gap is there. So you should have to give one wire from here to here. So it will gives you complete connection. And here you know that this is the horizontal is there. Between these two, here the vertical connection, which is always basic thing for this breadboard. So now let us see here. We are having 4 is always negative VCC and 7 is positive VCC. Now I will give that. Here positive is there, is the negative potential is there. So negative potential, that is goes to the 4. So I will give here from the 4 to negative, and here 7 to positive I can give. So it is plus 12, and here I got it here minus, and here we are having the another one, that is the ground, so I can give here. So that's all. This is what we have to do. And now we needed the last step of this circuit diagram. Output we needed here. For the output we are going to use this multimeter. As you can see here, we should have to fix this one for the DC voltage. So now let us see here. I can give this terminal. I can give the 6, which is the output, and another terminal is the grounding. I can give here. So that's all. So this is what the connection has been completed in the inverting amplifier. Here we should have to take the input voltage as 1 voltage. So right now here the list is the 2 voltage is there. So right now I am going to take, instead of 1 voltage, I am going to take the 2 voltage. You can take the 1 voltage if possible also. If you are having the eliminator like 1 voltage means you can take that one also. So now let us see here, just I kept the input voltage as a 2 volt. So now, and here the variables are there. 100 ohm, 10 ohm and 1 ohm, 1000 ohm is there, and 10,000 ohm is also there. So now just we are going to vary this one to the from 1 kilo ohm to 10 kilo ohm or else 5 kilo ohm. So now I have considered the 1 kilo ohm, just I have fixed for the 1 kilo ohm, which is the variable. And now let's see that input voltage is 2, I'll make it on. So now let us make it on. Okay, so now you can see the output here, how much we got it here for the 1 kilo ohm. As I have done this already, 1 kilo ohm is there. So with respect to that, what will be the input voltage is 2 voltage is there. Inverting is the sense what, whatever you are having the input, if this is the input means output must be what? It will be reverse of that. This is what the simply we can say that in generally this inverting of this input signal. Okay, so you can what we got it here, input is we are having the positive means output must what we have to get, we have to get the negative. And even though we are having the feedback resistance at 10 kilo ohm, if you change this one means again we are going to get the other values. Okay, so now simply we should have to know that what will be the voltage gain for this 1 kilo ohm of resistance. For the 1 kilo ohm of resistance we got it here minus 9.55. This is the output voltage. We can write it here minus 9.55. Okay, and this is the experimentally what we know that we know this is the gain, voltage gain is there, V naught by V input, and V naught output how much you got, minus 9.55 volt divided input how much we are having, we have considered the 2 voltage. So 9.55 divided by 2, and whatever we will get it here, which is approximately near to 4.56 or something like that, which is near to 5. So this is the voltage gain. This is experimentally, and theoretically if you want to find this one means simply the thing is what, that the voltage gain that is equals to minus RF by R1. That negative that indicates that there is an inverting is there. So what we got it here, if you are having the this much means minus is there, and here also you can get the minus. Feedback is 10 kilo ohm and input R1 is the input resistance. We are having the variable 1 kilo ohm is there. So it means to be what, minus 10 we got, and experimentally we got around 5, which is not much comparable with the theoretical value. Let us look into the next one. I can change this value to the 2 kilo ohm. You can see that you can observe this output values, that is minus 9.49. Theoretically we are having the minus 5, and experimentally what we got it here, minus 9.49 divided by 2 means what, I can get nearly 5. So it means to be what, the experimental value and the theoretical values are verified. Similarly theoretically 3.3, 2.5, 2 is there. Now let us look at here, I can change these values again, that reduces. It's a very simple Ohm's law, you can observe here. Let us change this on 3 kilo ohm, again that becomes minus 6.40, and again for the 4 kilo ohm, again that becomes minus 4.77, and again that becomes minus 3.79. As we are going to apply the resistance, with respect to that the output voltage gain is going to be reduces. So this is what we can see from this inverting amplifier and the verification of experimental and the theoretical value. In the similar way, we are having the non-inverting also. Very simple difference is that what we are having in the inverting, this input voltage has been connected to the second pin. From here to here, from the terminal 2 to 3, it's been shifted. So it means to be what, whatever you are having the input, that kind of output should be there in the non-inverting. It means to be what? If you are having the output sinusoidal wave like this, means you should have to get the what? Like this one. This is plus 180 degree and it must be plus 180 degree. In the inverting, what is going to be happen? If this is plus 180 degree shifting is there, and again here it will get the minus 180 degree. It's a very simple physics is there, and this is what all about this non-inverting. Here we can get the same again. We should have to make the connection. Simply what we have to take, simply just we have to remove this input voltage from the terminal 2 to the, we should have to substitute to the terminal 3 here. And even though you can see here, I will show you that connection also. This is what all about the inverting, and right now just I'll make it off so that you can see the non-inverting also. Right now I am shifting here. Let us look at here. I am going to remove this one, where simply what I need, this variable resistor is then I have to give to the grounding, that's all. And here from this, so again we can give from 3 to the, where I have to give here, from 3 I have given the ground. Just I'll remove this one. So from the 3 where I have to give to the positive. So positive means what? Here from positive terminal of the battery eliminator, it's been done, that's all. And the already negative one is the grounded. So it's a very simple connection, that's all. This is what the inverting. You can see the output also for this. Again fixed to the 1 kilo ohm. And here what we should have to get, we must have to get the positive values. Okay, so now let us see. Okay, so now you got it here. The first one 1 kilo ohm, again 2 kilo ohm, again 10.87, and 3 kilo ohm 8.3, and again 4 kilo ohm 6.76, and again 5.82. So these are the values already. Once we have done this, we got like this 3.8, 4.3, 2.8, 3.8, which is near to the theoretical value. So it's what all about the non-inverting amplifier. So that's all. Thank you.